Normally what we expect to happen when we plug into the quadratic formula, certainly if we have a quadratic equation that we met in the wild, what we expect to have happen is that we get two real number solutions. But it's possible that we'll get one real number solution or no real number solution. Let's see what that looks like. So in this first example, we have x squared plus 4x plus 3 equals 0. So a is 1, b is 4, c is 3, and we'll get x is negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 3 all over 2 times 1. So that'll be x equals negative 4 plus or minus the square root of, the square root of 4 all over 2. So one solution is x is negative 4 minus 2 over 2, which works out to negative 3. The other is x equals negative 4 plus 2 over 2, which works out to negative 1. Our solutions are negative 3 and negative 1. And if you looked at that quadratic equation and said, I bet I could solve that by factoring, you're right, you could. But we wanted to see how this works in the quadratic formula, and I chose an example where we'd get integer solutions just so that they were easy to look at. Here's our next quadratic equation, and this is going to have different behavior. This one's going to give us only one solution. So we're going to plug into the quadratic formula. We have a equals 1, b equals 4, c equals 4. So we'll have x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 4 all over 2 times 1. And when we work out the stuff inside the square root, we get x equals negative 4 plus or minus the square root of 0 all over 2. Square root of 0 is just 0. It doesn't matter if I add or subtract 0. I'll just get x equals negative 4 over 2. There's only one solution, it's negative 2. Right? Because negative 4 plus 0, negative 4 minus 0, they're both negative 4. This last equation is going to turn out to have no solution. So again, in the quadratic formula, we'll have a equals 1, b equals 4, and now c equals 7. The quadratic formula says our solutions are x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 7 all over 2 times 1. But that is x equals negative 4 plus or minus the square root of, the stuff inside that square root works out to negative 12 all over 2. And negative 12 doesn't have a real number square root. So as long as I'm thinking about only real numbers, this has no solution. And we notice that the thing that makes the difference between these behaviors is what happens with the square root part. When I'm taking the square root of a positive number, I have two solutions. When I'm taking the square root of 0, I have one solution. And when I'm trying to take the square root of a negative number, I have no solution. The number of solutions the equation has depends on the number inside the square root. And because it's often more important to know whether there is a solution than to know exactly what the solution is, we're often going to just look at that number. And so that number has a name. That number, b squared minus 4ac, that shows up inside the square root in the quadratic formula, is called the discriminant. And the discriminant determines the behavior of a quadratic equation. If the discriminant is positive, we have two solutions, because then we have plus or minus that square root. If the discriminant is exactly 0, we'll have one solution, because then we'll be taking plus or minus 0. And if the discriminant is a negative number, then there's no real solution, because we're trying to take a square root of something negative. Also, if the discriminant is a perfect square, we know the solutions are going to be rational. Otherwise, we know the solutions are going to be irrational. So we can either get a decimal approximation or give a simplified root. So in this next example, we don't care what the solutions are. We're just going to figure out how many there are by computing the discriminant. So in this equation, 3x squared minus 11x minus 5 equals 0. We have a equals 3, b equals negative 11, c equals negative 5. And so d is negative 11 squared minus 4 times 3 times negative 5. D is 181, which is a positive number. So this equation has two solutions. In this equation, t squared plus 5t plus 25 equals 0. We have a equals 1, b equals 5, c equals 25. So our discriminant is 5 squared minus 4 times 1 times 25. In other words, d equals negative 75, which is a negative number. And so this equation has no real solution. Finally, x squared plus 6x plus 9, we have a is 1, b is 6, c is 9. So our discriminant will be 6 squared minus 4 times 1 times 9. Oh, and that works out to 0. The discriminant is exactly 0. We have exactly one solution to this quadratic equation.